Hello and thank you for watching my video. My name is Astrid Krasniqi. I'm CCNA and CCNP certified instructor. On this video we are covering new topics added to the CCNA exam 200-125, and this is section 4.2 VPNs. Upon completion of this section, you should be able to describe site-to-site and remote access VPNs. For example, there are two types of VPN networks. We have site-to-site and remote access. Site-to-site VPN. A site-to-site VPN is created when a device on both sides of the VPN connection are aware of the VPN configuration in advance. The VPN remains static and internal hosts have no knowledge that VPN exists. Site-to-site VPNs connect the entire network to each other. For example, they are connecting a branch office network to company headquarters. The remote access VPN. A remote access VPN is created when the VPN information is not statically set up, but instead allows for dynamically changing information and can be enabled and disabled. VPN client software may need to be installed on mobile users and devices. Okay, so if I can open Paint and just show you very quickly, for example, what is site-to-site network, right? Here, for example, I have a headquarters, HQ, and further down here, I have, this is my BR1 or branch 1, for example. Let's just imagine that, yeah? So we have a say BR1. Now, in the site-to-site VPN, it's like when this router here, it creates a VPN with a router or branch. This VPN is statically, it's always going to be there. Right in here we're gonna have, for example, the internet. Yeah, so if I can just draw the internet like that, if I can fill a salty color red, that's our internet. The site-to-site VPN, our users, they don't know they are part of the VPN. So if you have, for example, user here is talking to a server here, they got no idea that it's part of the VPN. They can see the files are getting a bit slower and stuff, but they don't know it's they don't have to be interacting with the VPN at all. All they have to see, okay, well, I have here this IP address 10.1.1.1, for example, and this server here, maybe the IP address 10.1.1.2. They can be like that. They can be on the same subnet as well, right? This is a site-to-site VPN. Now, if, for example, if I can just delete this. Here, if I have the headquarters like we had before, so say if I put headquarters here, it's my HQ. Remote access VPN, this is HQ, and remote access VPN is like when the computer, so for example this computer wants to remotely connect to the headquarters. Now this user is dynamically, so it doesn't have an IP, it doesn't have a static IP address. Today is in London, tomorrow is in, I don't know, Paris, New York, or whatever. So dynamically is going to create, but like a VPN session. But on this computer, you have to have an application to install for it to work. So like a VPN client application. The benefits of the VPN would be, for example, cost saving. So you don't have to buy a dedicated link for each site. You just have to access to the broadband. You can create a VPN. As soon as you have access to the broadband, to the internet, you create a VPN, because VPN is secure. So we have a security there. We can enable security and scalability. We can create as many VPNs as we want, really. It's just a matter of the bandwidth. We're going to run out of bandwidth very quickly. More VPNs we create. So for example, one type of VPN, this is not secure, is GRE tunneling. So what you do with this is, for example, you go to the interface, and in the interface you give an IP address, public IP address. Make sure it's enabled. Then we say interface tunnel. We create in this tunnel point to point, from router 1 to router 2. Here could be hundreds of routers in the middle. Doesn't really matter. We need to tell what mode is it. For example, mode GRE is IP. We could say IPv6, for example. We tell the IP address of the tunnel, so 192.168.2.1, and then we need to tell the source of the tunnel and the destination of the tunnel. So source IP address is this. We could say interface card as well, interface ID, and we have to say the IP address of the destination. Then exit, and the tunnel, as long as this source can ping this destination, the tunnel will come up. In there we can enable routing protocols and it will work. So same, we can do it on the other side. It's like a mirror configuration. Tunnel 0, the IP address, it's on the same subnet. That's the tunnel's IP address. And we need to identify the source IP address and destination IP address of the tunnel. And then we type exit and enable the routing information, and we have a neighbor. Okay, so I have this network that we've been working with, right? So what we can do, for example, we want to create a tunnel between router 1 and router 4. For example, here I want to put a cloud, because even though that we know these routers, just imagine that we don't know, right? They have so many routers in here and we got no idea. But this tunnel to work, for this tunnel to work, this IP address, this interface should be able to ping this interface. And we can go and test that, try that. So we go to router 1, for example, and say ping, let me write it with small letters, ping 10.1.34.4, and we have a success. So we are halfway there. As long as we can ping, it's great. Now the one thing that we're going to do, we're going to create a tunnel. For example, we're making a tunnel from here to here, right? Let me just twist that, right, like this. Smaller. Here, that's our tunnel. From that interface to that interface, we're going to put the IP address of the tunnel, right? So this is the IP address of the tunnel. So let me just move this tunnel here, so we know that it's going to be the tunnel IP address on this interface. So IP address of this tunnel is going to have, let's pick something else, 192.168.1.1/24. And with same thing, we're going to do it on the other router. So on this side is going to have .1.2, but it has to be on the same subnet, you see. Our configuration would be, for example, I go to router 1 and say config T interface tunnel 0. Give an IP address, so IP address of the tunnel. So 192.168.1.1, subnet mask 255.255.255.0. Tunnel mode GRE IP. This is the default, you don't even need to configure this, it's already there. You can, for IPv6 for example, you would configure. Then tunnel source one, it's going to be 10.1.1.12, sorry, 10.1.12.1, and then tunnel destination is going to be 10.1.34.4. so destination is here, that's the one that we pinged earlier. Right, so you can see the tunnel already changed state to up. So it's already, the tunnel is working, but we have to configure on the other side, yeah? So we have to configure this side here. So for example, if I go to ping, for example, ping the tunnel 192, I haven't configured anything, so there's no even point to pinging. So I go to router 4, do similar configuration. So config T interface tunnel 0, IP address 192.168.1.2, and the subnet same /24, and then a tunnel mode GRE IP. Tunnel source is going to be 10.1.34.4. Tunnel destination is going to be 10.1.12.1. Cool. You can see now the tunnel has gone up. So show IP interface brief. They can see the tunnel interface is up. So if I ping the other side, so say ping 192.168.1.1, I can ping it right away. But what's happening is going through this, and we are going through our tunnel to get to the destination. So now I can run the routing protocol. So config T router EIGRP1, for example, network 192.168.1.0. And now if I do the same on router 1, config T router EIGRP1 network 192.168.1.0. Right away I got a neighbor in the tunnel. From the tunnel I got a neighbor. New adjacency is tunnel 0. So if I say show IP EIGRP neighbors, you can see that I got a neighbor 192.168.1.2 in the interface tunnel 0. So it's going through the tunnel, the protocol traffic. But GRE is unsecure. So if you do want to add security there, then you have to enable IPsec, for example. IPsec does work together with the GRE as well, so you could be using both together. So tunnel verification, show IP interface include tunnel, and we can see the tunnel, both the layer 1 and layer 2 is up. We can see the tunnel's IP address, and most important, the source of the tunnel, and then the destination of the tunnel. And whatever that's our mode, the IP, GRE IP is our default. And then we can see the routing protocols as well running through the tunnel. So you see point to point here and tunnel 0. One different type of tunnel that we can create is you can create a dynamic multi-point VPNs. Different types of VPN. Tunnel, VPN, same thing. Cisco software solution for building multiple VPNs in an easy, dynamic and scalable manner. Goal is simplified configuration while providing flexibility. Dynamic multi-point VPN topologies can use hub and spoke tunnels, hub to spoke and spoke to spoke tunnels. Dynamic multi-point VPNs is built from the following technologies: Next Hop Resolution Protocol, NHRP, Multipoint Generic Routing Protocol, mGRE tunnels, IP security or IPsec encryption. With the dynamic multipoint tunneling, what we can do is dynamically build these VPNs. Right? You can have the hub, and dynamically will build the VPNs with the spokes, and as well as it will allow other spokes to build a tunnel with each other dynamically. Just when the data needs to be sent, the VPN will be created then. It will not be there statically always. Thank you very much for watching my video. Please have a look at my other videos and don't forget to subscribe. This has been Astrid Krasniqi. Bye bye.